Hi class, it's Professor Rourke. I am making the video now that I mentioned in class, if you were there Monday, from 3.5 number 12. Okay, so I mentioned this problem is deceivingly tricky because at first it just seems like, okay, they give us some equation, they call it an ellipse, and then they also give you this point that it passes through. So you would think it was like the type of problem that we've seen a lot before, where they give us some equation, some function, something, and then they give us maybe the x value, and we plug it in to get out the y value, and we find the derivative, we plug in the x and the y, that's our slope, call it a day. Bada bing, bada boom, done. A lot of tangent lines that we've written over the course of this class. However, this one is, again, deceivingly tricky, because this is an ellipse and this is a point that is not on the ellipse. Okay, so I could spend some time with you just graphing this ellipse. That's probably something that you have done before. Whether or not you can recall it easily or not is another question. But remember, there's like a major axis, a minor axis. You have to divide everything by 81. So it'd be like x squared over, whatever we write it as, 9 squared plus y squared over 3 squared equals 1. So the major axis is 3. I'm sorry, the major axis is 9, the minor axis is 3. And long story short, though, this point is all the way over here at 27. So area's all the way over here. Okay, and this is a super rough sketch of what the ellipse is going to look like, just to kind of give you a quick visual of what's going on here. Not the best. I didn't even find the foci or anything like that. Okay. So it essentially is saying that we're going to have two equations, each a tangent to, I missed there, to the curve, but they also just happen to later on pass through 27.3. Okay, so it's deceivingly hard because we do not have the points that it actually does touch on my ellipse, okay? And we don't have the slopes. So we don't really have anything as of right now for my two lines. But we can find them using some trickery, some algebra. Okay, all right, so first things first, let's start with what we do know. I can call this, even though it's not going to be our equation of the line, x1, y1. This is x and y, right? And this is my equation of the ellipse. So what I could do is use implicit differentiation to find the derivative of that lovely ellipse. Okay, so I take the derivative of both sides, and I also don't forget that when I'm finding the derivative of y with respect to x, I include the dy dx. Okay, so I'm going to go ahead and get solve for dy dx, solve for my derivative with respect to x by subtracting 2x and then dividing by 18y. So it'll be negative 2x divided by 18y, which I could simplify like a little bit. And this is the same thing as negative x over 9y. Okay. So that's that. That's good, I guess. This is what my derivative is. I still don't have a point, however, so that's a problem. But this does help us a little bit, gives us some piece of information. So what we do from here is we can go ahead, and even though, again, we don't really have our x and our y point yet, we do know that this is going to be the slope. We, again, don't know have an x or a y point yet, but we do know that it eventually goes through this point over here. So what we'll do is we'll say y minus y1 equals m times x minus x, right? And we'll go ahead and substitute in there 3. And we'll replace the slope, even though we don't know exactly what it is because we don't have the point on the curve. We found the derivative of this ellipse, but we don't have all the information to be able to say, okay, at this point on my ellipse, the slope is blank. Okay, we just don't have that yet, but we can plug everything else in. All right, Again, this is where I call it trickery, but it's fine. It's going to be the same thing every time. Let's go ahead and just try to get, we're going to try to solve for x in terms of y, or see if we can get a little bit closer here. Okay, we're going to maybe get an x by itself or the y by itself, because we're really going to have to use a system of equations. We're missing two things. We're missing an x, we're missing a y. So we multiply everything by, clear out the fractions, we can multiply everything by 9y. So this would be 9y squared minus 27y equals, let's go ahead and distribute in that x while we're at it too. So this would be negative x squared over, nope, get rid of that. Negative, the 9y is gone. Negative x squared plus 27x. Okay, so this is where though, every time we're solving one of these, you might notice something. And this is again, something that unless you were kind of looking out for it, you probably wouldn't necessarily know to go in this direction. If I'm asking you to get x by itself, you're like, how would I do that? We can't isolate x because we have an x squared and an x, and we could factor out an x, but you can only factor and set each one equal to something if it's zero using the zero product property. So what we can maybe notice instead is we can't really get anything by itself. However, we can use some more piece of information. So we know that x squared plus y squared is 81. We have x squared plus 9y squared, sorry. And no matter what your numbers were to start out with, that you will have something sort of similar to this, where you don't have it written that way right now, x squared plus y, 9y squared, but we can do a little bit of algebra. We could add x squared to both sides to get x squared plus 9y squared. And then we could also add 27y to both sides. Okay, so we'll have x squared plus 9y squared equals 27x plus 27y. Okay, why are we doing that? Because we're trying to just use the pieces of information that we do now. X squared plus y squared is 81. So we can say 81 equals 27x plus 27y. So the whole reason we did that was so we could solve for one of these variables in terms of the other, and then we're almost close to being able to set up like a system of equations. Okay, so from here, we can go ahead and pick whichever variable you'd rather get by itself. It's totally up to you. Let's go x, we'll get x by itself. So we'll subtract 27y from both sides and also divide everything by 27. So all this comes down to x equals, right over here, a little unusual formatting, but that's okay, 3 minus y. Okay, so again, we're not really still sure what's going on, but we know that these this point on these graphs are going to have a relationship of x equals 3 minus y. You could have solved the other way if you wanted to. Okay, so what we're going to do now that we have that one piece of extra information, we think about all the stuff that we do know. This is, and we know that it's somewhere on this equation. And we also know that we know the relationship between the x and the y coordinates is going to be x equals 3 minus y. So with this piece here and this piece here, we have enough information to solve. So I'm going to go ahead and wipe out a couple of the things here that we used from before that we have down. Remember that what I pretty much erased there was that m is going to equal negative x over 9y. I have that written here again. So, okay. So what we're going to do is we have x squared plus 9y squared equals 81, and we know that x equals 3 minus y. So that's the big piece here that we need to remember, is that we can substitute in 3 minus y now and for x, and now we're left with an equation with all y's. So that's good. We're going to go ahead and FOIL out 3 minus y squared. That'd be 9 minus 6y plus y squared plus 9y squared equals 81. And it might not feel like it, but we can solve this. Okay, let's see. This would be, we can combine the y squareds together to be 10y squared. I'm kind of setting it up like it's going to be maybe quadratic. Let's go ahead and subtract the 81 from both sides. So 9 minus 81 would be negative 72 equals 0. And then we can factor this to solve. It's been a while since we had to factor anything. Let's go and take out the greatest common factor. At least I can take out a 2, so that's something. So we're left with 5y squared minus 3y minus 36 equals 0. Now, we really haven't seen much in factoring in this class. So we can do two things. We can do guess and check, or we can do the AC method. It's totally up to you, depending on what you feel comfortable with. The 2 is pretty much unessential right now. It's done because 2 can never equal 0. So that's pretty much gone. But we can either do, again, guess and check, where what you do is you take a combination of the first 2 terms that would multiply together to give you 5y squared. And you think about what numbers that 36 could be broken up into, so that if we were supposed to be FOILed back out, we would get negative 3y in the middle term. So you can try some things out. Let's see, 36 could be 1 and 36. It could be 2 and 18. It could be 3 and 12. 36 is one of those rude ones. There's a bunch of them. 4 and 8, or it could be 6 and 6. So you start really kind of wherever you want. Let's go, I don't know, negative 4 and positive 8, and give it a try. Okay, so you would say these FOIL out to give me the correct first and last terms, but we have to check the middle term. So 8 times y is positive 8y, 5 times negative 4 is negative 20, negative 20 plus 8 is negative 12. I need to be negative 3. Okay, so that's not the one we're looking for. So we try a different combination. Let's say 3 and 12. Okay, so it would be 5y times negative 3 is negative 15, positive 12y times 12 times y is positive 12y. That's the combination we're looking for. Okay, so we set each one equal to 0, y equals negative 12 over 5, and y equals 3. Or, depending on your previous math class, you might have approached this by factoring using the AC method, which is totally valid too. That's where you multiply 5 times negative 36 together. What is 5 times negative 36? That would be, negative 180. Okay, so then you have negative 180. So you think 2 numbers that multiply together to be negative 180, but add up to be negative 3. Then you break up this middle term into whatever those 2 numbers are, and then you factor by grouping. Okay, so however you do it, whether you do guess and check, which is what we did here, or you do AC method, hopefully either way you should be able to get 5y plus 12 times y minus 3. Let me know for sure if the factoring is tricky at all. So then we can come down to y equals negative 12 over 5 and y equals 3. So those are my 2 y coordinates for my equation. Okay, and then we're almost done. We just need to get out the x coordinates that go with that. Okay, so I'm going to go ahead and erase this stuff again, some of this stuff at least, because I can eraser before times on a chalkboard. Okay, so, okay, I think that should be enough to go off of for now. And the other piece that had gotten erased somewhere along there is that we did solve before, if you remember, to say that x equals 3 minus y. Do you remember that? So we got our y's out finally, and now we're going to go ahead and we can substitute in what we got for our y value. So here we have, we'll do negative 12/5 first. You know, save the harder one, get the harder one out of the way. This is like 3 plus 12 over 5. And if we get a common denominator, this would be like 15 plus 12. So that'd be 27 over 5. Okay, so this means one of my points is going to be 27 over 5, comma, negative 12 over 5. That's my 1 point. That's probably going to be this guy here, just in my rough sketch. ish. And then my other point is going to be when I plug in 3, and 3 minus 3 is just 0. Okay, so my other point is 0, 3. Okay, and that makes sense. That's this guy. Okay, so those are my 2 points. I now have enough information to actually find what the slope is, because now I can actually plug that in to negative x divided by 9y and write my equations out that way, because that's what they actually want us to do. So that's why this one was a lot. It's number 12. So, you know, sometimes they do that at the end. Just have you solve a problem that has you pulling all kinds of prior knowledge in. Okay, so we're almost done. Let's see, we have y minus, I'm going to go ahead and recopy what we have here. 3 equals negative xy over 9y, and negative x over 9y times x minus 27. Remember, that's kind of where we started, just with the point and the slope that we were able to get down to negative x over 9y, but until we knew a point that was actually on that curve, we couldn't go much further. But now we can actually do that. We can go ahead and plug in. We'll plug in, again, we'll do the fraction one first, harder one first. Let's see, and technically they say larger slope and smaller slope, so we'll figure that out now too. So let's say y minus 3 equals, and I'll do this carefully because it's fractions within fractions, so that's always good. So it's negative x, I'll say negative 27 over 5 divided by 9 times y, which is negative 12 over 5. And then this is x minus 27. Okay, so we have some fractions within fractions to have to worry about. I'll go ahead and take it on over here. A little side note. This is like negative 27 over 5 times the reciprocal, which is 5. Negative 9 times 12 is 108. Okay, so the 5s cancel out, and we're essentially left with 27 divided by 108, and it's going to be positive, right? Because the two negatives, and that's just a 1/4. So all of that comes down to y minus 3 equals 1/4 times x minus 27. You wouldn't think we had to do that much to get to that. That's my one equation. So the one slope is 1/4. And then the other slope, if we plug it in, you can you might sort of see what you think it's going to be already. It's going to be y minus 3 equals x is 0. So for another point, so it'll just be 0. The slope is 0 times x minus 27, which this is one of those funky ones where the 0 is going to essentially wipe everything out. So we're left with y minus 3 equals 0. I wonder if WebAssign lets you put it in like that, or that's probably easier to think about. This is just the line y equals 3, which does kind of make sense off of our terrible sketch that we started out with. Okay, so smaller slope, technically, I guess the slope of 0 would be the smaller slope. That's no slope. So we'll say y equals 3. Oh, I didn't realize they have y by itself. So we can do that. I have it in point slope here. And so we'll fix that up here. Okay, so if I distribute it in the 1/4, it's like 27 divided by 4. And then we have to add 3 to both sides. So let's see, that would be like plus 9. No, plus 12. So I'm going to rewrite this as y equals 1/4 x plus 39 over 4. So that was a little rude there, but that's okay. So we'll do that 1/4 x plus 39 over 4. Okay, so hopefully that made sense. I know, again, that was a lot. Just to kind of recap, if we try to go back and backtrack, first we used implicit differentiation. Then we tried to write an equation for the line that is has a point that is tangent to the ellipse. There's 2 of them. And then it goes all the way over here. So we don't really know what the slope is yet. So what we had to do is we had to do some trickery to get it down to x equals 3 minus y, because remember we pretty much like cleared out the fractions and then got x squared plus 9y squared equals 81. So we could replace 81 equals all that stuff, and we got that x equals 3 minus y. We used that to get out what X and Y were, 0, 3, and 27/5 and negative 12/5. And then we could use that to finally write the equations of the line. So very involved problem. And please let me know if I can help answer any questions from that. Thanks.